Hi, welcome to the evaluation of expression tree. The binary tree is associated with any kind of arithmetic expression. So here the tree is representing uh, operators in internal nodes. So operators are represented in the internal nodes of the tree, and leaf nodes or external nodes always will be either operands or numbers. Operands in the sense numbers are variables. Numbers are variables. The operators which is available in depth, more depth, will have highest priority than the lower depth. So here, which is the depth is 2, here its depth is 1. So this is having more priority than the into mark in the depth 1. Like that, the operands variables are numbers which is available in the highest depth. Here the variables a and number 1 is available at the depth 3. The 2 is available in the depth 2. So this depth 3 operands are having more priority than the less or lower depth operands. The use of an expression tree here, which is used to represent the associativity, that means which is having more priority, I mean precedence level, right associative or left associative. So that associativity can be represented by using the expression tree. And here the expression tree will be given as a input, and each node will have the character that may be a operator or operand. If it is operand, then it will return the node dot data, or we have to identify the left value and right value. Then we can apply the operator uh, between two operands to calculate the value. So here the data is given. uh, the first we are passing the symbol plus. So when we are passing the symbol plus here, when we are passing the symbol plus here, so immediately which is checking with root dot left, root dot right. So here the root dot left equal to null, so which is false. So now the control will come to the root dot left. So in the root dot left, so this is the plus. So for plus we have to call evaluation tree. So for root dot left we have to call evaluation of tree for the plus dot left, plus dot left. So for plus dot left, here we are having uh, into mark, into mark. So for that, again we will pass again recursion. So here now the evaluation tree, again for we have to call evaluation of into mark dot left, into mark dot left. So for that into mark dot left, so into mark dot left is 2. So now we are passing the 2. Then here we will get the value left value equal to 2. Then next one, root dot right. So what is the root here? Plus sorry, into mark is the root, into mark is the root, right? So right value we have to find out. Evaluation tree of into mark dot right. So into mark dot right we are having here minus, so the symbol minus, right? So now we are having the minus here. Again we are calling the evaluation tree here. So for that, here we will get evaluation of evaluation the l value for minus, right? So here l value equal to evaluation tree of minus dot left. So minus dot left we will pass the value 5. Then this is assigned to the, this is assigned to the l value. So here look at that, we are passing the 5. Then 5 is here root equal to null, it is false. Then 5 dot left is null, yes. 5 dot right is also null. Then 5 is passing to the digit underscore identify. Here we are passing the value 5 because it is passing as a character, which is passing as a string or character. For so we have, for that we have to get the numerical value. For that we are reading that location character at the string, so that is the 5. So 5 not equal to minus, yes, it is true. Then we are checking length of the string, it is 1. So so now we are checking 0th iteration, the character is passing here, so 5. So 5 value is actually we are getting the ASCII value. ASCII value is 53. So 53 minus 48, we will get the 5. So initially number is 0. So 0 into 10, 0. So here 0 plus 5, we will get the number is 5. So now 5 is passing into the 5 is passing into the here 5 is passing into the L value. Then R value we have to calculate. R value here for the evaluation tree we have to calculate minus dot right. What is the minus? Minus is the root node. Here minus dot right is 1. So here we are getting the 1. So for this 1, we again we have to pass as a root node. So when we are passing as a root node, here this condition will be false. Now 1 dot left equal to null, 1 dot right also null. Yes, 1 dot left is null, 1 dot right also null. So now we are passing the digit underscore identify. Now 1 is passing to this method. Here again in this place we are getting the 1. So 1 is passing here, so number is 0. Then we are checking 1 is the place, so the 0th index is having 1, so which is not a minus. So which is starting from 0th iteration. Now again reading the character value 1. 1 is as character value is 49 minus 48, we will get 1. So 1 is assigned here. So 0 into 10, 0. So 0 plus 1 will be 1. So number 1 is assigned to the number, so which is returning now. So now R value we are getting here is 1. So now for the minus, for the minus we got left value and right value. So for root is now minus, root is now minus as per this location, root is now minus. So if root dot data, so root dot data is minus, so minus equal to minus. Okay, so that's what we have given here. So here this is becoming false, this is becoming true. So we are evaluating this one. So left value is here already we got, that is 5. Right value is 1. So we got value 4. So which is returning 4. Where it is returning? This is returning to the R value here. We are instead of the, so this 4 is replacing this minus. This 4 is, this result of this is replacing this right child. So now we got right child for the into mark. So right child for the into mark, that is the value is now 4. So now we got the 4 as a R value here. Then now we can say evaluation of this tree, right, subtree, this subtree, right. So if into mark equal to into mark, so then we will return the 2 is the L value, 4 is the R value, so we will return the 8. So 8 is written here to the plus. So here we have called evaluation of tree, right, root first at the initial stage we have called the plus. So for the plus, okay, for the plus dot left, so plus dot left, so this is the plus dot left. So here we sorry, this is the plus. For the plus dot left, star is there, this one plus dot left is star. So in this place we are giving the value this 8, giving the value this 8. So after that now we have to call plus dot right, plus dot right. So plus dot right still we didn't call, only we have called plus dot left, plus dot left only we have called. So now we have to call R value. So this is L value, okay, this is assigned to L value here, this is the L value which is assigned here. So now we have to call plus dot right. So plus dot right will be assigned to the R value. So when you are calculating that, you will get plus dot right will be the into mark. So for that into mark, again you have to apply the same procedure. You will get the value 6. So now you got R value for the plus, L value for the plus. Then you can apply this method. So here our root value is plus, so the L value plus R value, you will get 8 plus 6, you will get the 14. So this is the procedure to calculate the expression by using express entry. Thanks for watching.